Welcome to all. This is the workflow demonstration of our new molecular docking software, that is MzDock, which is absolutely free for academic users, and it is the collaborative work between Amrita School of Pharmacy and University of Barry. So this is my research team who are actively participated for the development of this particular software. So as you know that an academic software has many drawbacks: the accuracy of results, the generation of various confirmations. But apart from that, so we will try to compensate all such type of problems in this small platform. So let us see that what are the steps commonly involved for the commencement of our software program. So commonly we have 5 steps for the workflow of our software. So normally the first process is the ligand preparation, second is the protein preparation, and the third is the defining the binding site, exclusively the active binding site of the protein, and run the docking simulation, and finally analyze the interaction with the help of some external source. So first of all, I'm just opening our MzDock. So by opening this, you can see there are 2 platforms. This is the input platform. The terminal is the output platform. So here only I'm giving the commands. On the base of the command, you can see the generation of the results in this particular area. So my first step is I'm just opening the new or start. So from that new, I should select the ligand. So here I select my ligand on the basis of various saved format. You know that the ligands can be constructed by the use of an external source, either by ChemSketch, OpenBabel, ChemDraw, any platform you can use that. So we gave a wide opportunity to save in a different format, something like Smiley's format, MOL, SDF, PDB, MOL2 format. So 5 formats we used for the construction of our molecules. So here I choose the MOL format, and also this is a force field which we used commonly for the energy minimization, and also we have another option is there, enantiomer. Suppose if your molecule has some R and S conformation, so at that particular time, so you can use this option also. And already I told you know that I saved my molecule in the desktop by the use of this small format. In the desktop I saved, this is a folder which I saved already, chalcone. That is this is a chalcone is my molecule which I will use for my docking calculation. Okay, so once I click, you can see that there is a command box came, successfully selected the ligands. So suppose you can use number of ligands also, because here I used only 1 ligand. You can use more ligand also at the same time itself. That is another advantage of our software. So you can make an option of click. So already I told you know that our force field, I selected the MMF 94. Then you can go for the option of prepare. So can you see that in the output file it will generate the energy minimization. So finally again, and command box came with a comment of the ligands are successfully prepared and is ready to dock. You can go for the confirmation by clicking an option of OK. So once you made that option, so you see here already the first step is over, because I think that you can see it is visible as thick letters. So that is you can see that the first step is over. So next step is we want to select your protein. Then there we are using the 2,5-Z, that is a monoamine oxidase enzyme B is the enzyme we are employing for the docking simulation. So again, after clicking, you can go for the option of OK. So here this particular enzyme, it is a dimer form, so you can select any one form. So I choose only one. So then you can extract the remaining chain. So after that you can go for the prepare. So prepare itself, we have a 4 option. You can add hydrogen, and you can add the charges. We used the Coleman charges. You can clean up the water or keep the water. Some of the docking studies we need to keep the water. So here I'm just removing all the water, and the ligand also I'm just making the manual type of. Then I can go for the conform. So if you want to add the ions, some metals, if it is necessary to if it is necessary to use for your docking calculation, that also you can make an option. Then you can go for the conform. Then after that you will get another option. You can make OK. Then the third step is you want to make the binding site configuration. That is one of the important things, because binding site configuration is in every protein there is an inhibitor binding cavity is there, where you can see the native inhibitor which can produce maximum interaction. So that particular area you should isolate initially to identify whether this particular binding site is able to produce some optimum interaction or not. So that's why this option I am using for that. So you can go for the selective ligand. So then you see here, this is I told you now that monoamine oxidase, it's a co-crystallized ligand with sulfonamide and a FAD dependent. This is a FAD dependent, this is a cofactor. And another option, if you're clicking the right click, you can see that this is a native inhibitor, that is a sulfonamide, which has highest binding affinity towards your enzyme. Then you can go for an option of conform. You will get another command box. You please go to the OK. Then you go to the prepare. So by preparing this, you will go for the binding site is defined for your docking. Then so you have docking 9 confirmation. You can generate up to 50 confirmation we can generate in our software. So you go for the 4th step, that is run docking calculation. So you can see that in the terminal, you can see that you see here from the minus 8.7 to minus 9.6, you can see that up to it's a somewhat good value. So minus 9.6 is the highest binding energy in the that is your first ranked conformer. So you can make an option of OK. So after that you saved in your MzDock folder, which is available in the desktop. You go to this that option. Then again you can receive another confirmation box. You please proceed with OK. Then the final step is analysis, because our software doesn't have an analyzing platform, so we are using some other external platform for the analyzation. So for that, so once you are making the docking complex, so you will get a complex with the PDB-QT. That PDB-QT is compatible with an external source. So I'm using PyMol as the external source for analyzing the interaction. So I can go for this interaction. Then this option I will click that. Can you see that? So this is the first. I already told you that this is the first conformer. First rank is minus 9.6. So I am just taking this option, that is this particular conformer. Then it is saved. So once it is saved, okay, so then you will get, you see here, you will get a command box, successfully analyzed your PDB complex. If this command will appear on your software, so then you can see, you can go for the option of OK. Again, you go to your desktop, then your MzDock So can you see that your folder name already it appeared? You go to the select folder, then you see here results are saved. Okay, you confirmed by clicking OK. So then you please, because you all the file you saved in the terminal, then you want to generate the output and finally identify that how the interaction is efficiently possible in this particular docking simulation. You can type simply PyMol. You can easily download from PyMol from the Google itself. So you can go for the option of open. Okay, it is open. So now I think you can go for this MzDock. You can minimize, then you can go for your PyMol. Okay, then this is the you can see that complex protein UNLA1.pc, that is PSC file, that is a file which is generated. You please drag your file to this particular software. So by dragging the software, you see here, you can see the three-dimensional aspect of your interaction. This three-dimensional aspect exclusively you can see in your PyMol software. So here you can see that the yellow colored, that is your ligand molecule. This one is your ligand molecule. This is the amino acids which is surrounded your molecule. So there are two types of interaction. You can see that. What is that? The first interaction is a blue colored interaction between your carbonyl group of your chalcone and your amino acids. That is a blue interaction, that is a hydrogen bond interaction. So by knowing the hydrogen bond interaction, what you should do that, so you please click this residue and you please go to the right click and show and you can go for the label option and the residues, you please click it, then you. So I told you that there are two types of interaction. First interaction is hydrogen bonding interaction. If you want to know the hydrogen bonding interaction site, you please click this particular amino acid residue. I think the amino acid residue is selected. You go to the label and the label you make an option of residues. You will get that glycine 2,6. In that you can see the hydrogen bonding interaction between the carbonyl group and your glycine amino acid, and some other interactions also you can see that which is visible in your in your PyMol version. So this version, I can tell you that this is hydrophobic interaction. There are two type of hydrophobic interaction is there, that is pi hydrophobic interaction, pi alkyl interactions are there. So here exclusively pi alkyl interactions are there. So there is no pi stacking interaction. That means between two benzene system there is no interaction as there. So these are the two types of interaction you can see after the docking simulation with your chalcone and the protein, that is monoamine oxidase enzyme B.